Hello, everyone. I'm James Henley, Director of RDA Toolkit. I want to thank you all for joining us for today's webinar from Damian Iseminger of the Library of Congress and our technical liaison for RDA. So I'm going to turn it promptly over to Damian.
All right. Thank you, Jamie, and thank you for inviting me here, and thank you for coming to listen to me. So let me share my slides here, and we'll start the show here. All right. And just confirming with Jamie that you're seeing the full slide.
Correct. Looks
All
good.
right. All right. Thank you. So I'm here to talk to you today about making RDA work for you in the context of leveraging the semantic coherency of the RDA element set. And just before we begin, just to reintroduce myself, I'm Damian Iseminger. My day job is working for the Music Bibliographic Access section in the Music Division at the Library of Congress. And then the other part of my day that occupies me is being the Technical Team Liaison Officer for the RDA Steering Committee. And since we have a large crowd here today too, I also want to take the opportunity that if anyone is interested in serving on the technical working group, of which I am the chair, please contact me directly. And we are always looking for more participants in the technical working group. I find the work enthralling and interesting, and hopefully with this presentation, you'll also decide that you want to contribute as well. So once again, thank you for coming. So to continue the talk, let's just go over the RDA element set in sort of a big paint by numbers way, big big 30,000 foot overview, if you will. So this is the RDA element set by the numbers. There are 13 entities. Those entities are named the RDA entity, work, expression, manifestation, item, agent, person, collective agent, corporate body, family, nomen, place, and time span. And we'll get into how those entities are structured with one another a little bit later. There are 3,024 elements. And we could break those down into what we would call relationship elements. That is, that they have a domain and a range of one of the RDA entities. There are 2,715 relationship elements. Or the elements are what we would call attribute elements. And those are attributes that only have a domain of one of the RDA entities. One of the most common of those are things like content type is an element whose range, its domain is expression, but its range is the value vocabulary for content type. We also have 4 different recording methods, and the reason for the 4 different recording methods in RDA is that people have different implementation scenarios. Some people are working with one set of applications that requires one thing while others are doing something else. So we have the unstructured recording method, and this is a literal value that is free text. It's a utility in that it provides keywords for people to search. There's the structured recording method. It's a literal value that is formatted according to a string encoding scheme, or it's taken from a vocabulary encoding scheme. For many of the people that are here at this webinar, a string encoding scheme would be, well, how do we format the access point for an agent or for a person or for a corporate body? And a vocabulary encoding scheme, you could consider something such as the NACO authority file as being a vocabulary encoding scheme. LCSH is a vocabulary encoding scheme, and so on. We also have the identifier recording method. That's a literal value that consists of alphanumeric characters that are independent of human language. Think of things like ISBN or ISNI. And finally, we have the IRI method. And that is if you are doing a linked data implementation of RDA, it's a value that is an RDF identifier. That RDF identifier is the thing we're talking about, not just an identifier for the thing. It is the thing. So when you factor in the entities and the number of elements and the recording methods, there are 11,422 possible ways to record RDA data. Now, this number is meant to sort of jolt you up, to open your eyes, but in reality, that's if you used every single RDA element, this is what you could possibly do with it. But we have ways to manage this sort of stuff, and now we're going to get into how we would go about managing it. So as I said before, we're going to go over the semantic structure here, and let's first go with the entities. So at the top of the food chain, we have the RDA entity. This is the top level entity of everything in RDA. So on the left of this slide, you'll see the familiar elements of work. The familiar entities of work, expression, manifestation, and items. These are entity subtypes of the RDA entity. Then we have this group of entities, and we call these the agent entities. So agent is an entity subtype of RDA entity. And then underneath agent, we have its various entity subtypes. There's person. Then we have collective agent, which is broken down into corporate body and family. And then we have three other entities because we often encounter these in cataloging. And so they, in the LRM model, they are their own entities. And these are place, obviously found with things like place of publication, the time span when something happens, and then finally nomen. And that's how the strings that we use to name things. So the way we relate all of these entities to one another using the elements is that we use what's called a high-level matrix. So all of the RDA relationship elements, they exist in a semantic matrix with one another. So for each entity, for each of the 13 entities, they are related to one another through high-level relationships. That is in the form of has-related RDA entity of RDA entity. So if you take 13 and multiply it by itself, that means you have 169 high-level elements. So then all of the RDA relationships are refinements of those high-level relationships. So let me show you an example of what I'm talking about. So here we have a high-level relationship element, has related work of work. It relates a work to another work. So one of the paths that we can go down is this path that's on your left. So the has transformation relationship is an element subtype of has related work of work. Has transformation by genre of has transformation. Has derivative work is a subproperty of that. And then finally, we get all the way down to the bottom of this and we have is abridged as work. On the other side here, you're seeing the inverses of these same elements. So then has related work of work, it is in a polyhierarchical relationship with has related RDA entity of work and has related work of RDA entity. And then finally, those two elements are related to the top element level in the whole hierarchy, has related RDA entity of RDA entity. So you can see here in just as one example how the elements are connected to one another. And then finally, just for completion's sake, each of the inverses are connected to one another using the OWL inverse of properties and RDA reference. And that just fills out the whole. So that's just a broad overview of how all of the elements in RDA are structured. Now let's talk about the agents. So to account for the relationships between the different types of agents, each kind of agent relationship is related to its broader agent element supertype, as well as its broader relationship within a specific agent hierarchy. And once again, it just makes more sense to show you what I'm talking about here. So take, for instance, this element called has screenwriter person. So if we stay within the person hierarchy, The next level up from that is has author person, has creator person of work, has related person of work. But a person is also an agent, if you recall. So has screenwriter person is also in a polyhierarchical relationship with has screenwriter agent, has author agent, has creator agent of work, and has related agent of work. And because of the polyhierarchical nature, we can also say that has author person is a subproperty of has author agent, has creator person of work is a subproperty of has creator agent of work, and has related person of work is a subproperty of has related agent of work. Then just so we know that everything is connected to the topmost element, we see the rest of the elements within the hierarchy. Has related person of RDA entity, which and then we have has related agent of RDA entity. That is the supertype of both has related agent of work and has related person of RDA entity. Has related RDA entity of work is a supertype to has related agent of work. And then finally, both of those elements are subtypes of has related RDA entity of RDA entity. Then the next part I want to show you as far as the semantic structure, and that has to do with the appellations. So there are several different types of appellations exist for naming the RDA entities. In the unstructured description, it could be the name or the title of an entity in natural language. A structured description is an access point for an entity taken from a vocabulary encoding scheme or formatted according to a string encoding scheme. And the identifier, a string that is a code or a number used to identify an entity. Once again, these exist in hierarchies. Has related RDA entity of RDA entity is the topmost one. Underneath that is has related nomen of RDA entity. And now we get to the appellation process. And this diagram shows the structure for all the names and how they would appear for every single entity in the toolkit. I'm just using the topmost element as the example here. So on the left, you have the unstructured description bit of the hierarchy. So remember, this is in natural language. It's not structured. It's a take what you see approach. So you have has name of RDA entity, and then that's broken down into preferred name and variant name. On the right here, we have the structured description. So these are the access points, and these are things that many of you are probably very familiar with. That's broken down to authorized access points and variant access points. And then finally, we have the identifier, and that's the subtype of appellation of RDA entity. So you could see from what I've shown so far that there are certain semantic structures embedded all over the RDA element set. But we can use these semantics to manage the element set to what you want to use. RDA has to throw a wide net and provide many elements because people have found uses for these elements, but it does not mean that everyone will be using these elements. So we have to find a way to manage them. So one of the ways that we can use the semantics to manage things is that we can choose elements at whatever level of the hierarchy that is appropriate. It may be based on costs, it may be based on user needs, or any other criteria that is deemed important for describing resources. So the semantic coherency of RDA ensures that applications that use a verbose RDA, they want to use as many RDA elements as is feasible for a resource that they're describing. It can still be understood by applications that use a slimmed down version of RDA. Now, the important caveat to all of this is that more granular metadata can always be generalized to something more coarse. That means we can go from the more specific up the hierarchy, no problem. The thing is that if you start off coarse, you cannot get more granular. In other words, the opposite is not true. So if you start at a very general place in the hierarchy, you aren't going to be able to get more specific. But the important point is that one application using a a really robust RDA still can talk with some knowledge with one that uses a more slim version of RDA. And so let's show you some practical examples of what I'm talking about here. So let's talk about managing the agent elements. So there's a lot of math here, but I've laid it out. There are 1,014 elements that have a range of entity or its entity subtypes. So that's what that means is that the domain is one of the other RDA entity. It could be any of the RDA entities, but its range is an agent. So there are 179 elements that have a range of agent, but they also have parallel elements with the other agent entity subtypes, and there's 716 of those. So what I'm talking about is something like, let's take a example like has author person. Well, there also exists has author collective agent, has author corporate body, has author family, and has author agent. So basically from one has author agent, we've generated four other relationships. This is what I mean by parallel elements. On the other side, we also have 1,053 elements that have a domain of agent or its entity subtypes. So 185 elements that have a domain of agent also have parallel elements with the other agent entity subtypes. So to go back to our example, the inverse where you could have the domain being an agent, you could say is author agent of, and then going down is author person of, is author collective agent of, and so on and so forth. So, and this is a hypothetical here. This is not something I'm recommending or condoning. It's just that so if you wanted to approach things this way, you can. So you could make a decision to only use agent elements. That means that for any agent you're describing, you're just going to use the stuff that is at the agent level. That results in the RDA element set being reduced by 1,456 elements. And that's nearly half of the total number of RDA elements. So just by this one trick, just to decide, well, I'm going to be coarse and I'm only going to describe agents. I don't care if the element is for a person or a corporate body or whatever. I'm just going to do agent. This is what can happen. This slide, we're going to talk about managing related agents of resource entities. And what do I mean here? So these are all the related agent elements of the WEMI entities. They are either in a hierarchical structure with related agent of work, expression, manifestation, item, etc., or creator agent of work, expression, manifestation, etc. So if you remember from the old RDA, the appendix J, I believe it is, and they're all I or J, I can't remember which now. But there's all of these relationship designators. And in fact, there's 1,014 of them. Those could be reduced now to between 8 and 40, depending on decisions that are also reached regarding the use of the agent elements and their subtypes. So once again, an example here. So this is the hierarchy for has screenwriter of person, taken up to related agent of work. Well, let's just say I don't care about distinguishing between the different types of agents. I just want to use creator agent and related agent. That's all I need. I don't care if it's a screenwriter. I don't care if it's an author. These are defensible choices that we might feel like we don't need to have specific relationship elements for that. And as I said before, you could decide, well, maybe I only want to use the agent elements. Well, you've also eliminated those two. But because everything is in a semantic matrix with one another, these decisions don't mean that things break. It just means that things can still talk to one another, maybe in a more limited way. But still, this is a way of managing things. And then let's talk about managing the appellation elements. So depending on the application, choices can be made concerning which appellation elements would be used. So there's the traditional library catalog. So The entities of interest are accessed through a series of authoritative labels that are unique, with cross-references pointing from variant forms. And so the appellation elements that we should be using for this should be associated with the structured recording method. And as a reminder, these are the types of elements that we're talking about, the access point elements. But we might be moving into a time where we don't have traditional library catalogs. Maybe we're talking about relational databases. And in this instance, entities are managed in tables with a unique key for each instance of an entity. So labels for the entity do not need to be unique because they're unique by their key. And so in this case, we could use the unstructured description method as a way of naming our entities. So we could just use the name of entities, has name of, has preferred name of, has variant name, because we don't need the highly structured string. Or to take it a step further, maybe I don't need to decide what's a preferred name or a variant name. Maybe all I need to say is, well, this is my preferred name for this, and these are the rest of these people's names. And so you just use those two elements. Once again, this isn't a recommendation. That's just a way that people could approach things. So we've talked about the semantic coherency. We've shown examples of how you can use the semantics to limit the number of elements that you use. And then the next big thing is then you need to build your own element set. And what I mean by this is that RDA has a very small floor for what is an appropriate RDA record. And these are the things that you sort of need to include. So we'll talk about here the coherent description of an information resource. So these are the elements that relate the WEMI resource entities to one another. And the bare minimum that RDA has is that describe one resource entity. So describe either a work, an expression, a manifestation, or item, and you relate it to another resource entity using one of the primary relationships. So just as a reminder, here we have the information resource model in RDA. We have the work, expression, manifestation, and item. And these are each related to one another through these primary relationships. So item is related to the manifestation that is exemplified through manifestation exemplified. We keep on going up, expression manifested, and then work expressed, and then the inverses of these. So that's the information resource model. So then the minimum description of a resource entity. So we know how to relate the entities. So how much of an entity do I have to describe before it's RDA compliant? Well, it only requires the entity to be named using an appellation element. So, and then for all of the other entities, excluding nomen, it only requires the entity to be named using an appellation element. So that's it. That's all that RDA requires. That is the barest of minimum that RDA requires. And you're probably thinking to yourself, well, that doesn't seem very useful, and you would be correct. And that's where we get into effective description. So then elements are selected because they may be applicable to most information resources, or they're selected because they are needed for specialized description. So then the trick is determining which elements will be selected. They're dependent on a variety of factors. And building your own element set leads into the idea of an application profile. So in the context of RDA, an application profile specifies the entities, elements, and vocabulary encoding schemes that are expected in a set of metadata that meets the functions and requirements of an application that uses the metadata. So the things that we're talking about in an application profile that should be decided upon, you need to decide what entities must be used, meaning whenever you do a description, you always have to describe this entity. Which entities should be used, meaning these are available for your use, or which entities you're not going to use at all. Then we get into the elements. These are the things that relate the entities to one another. So then elements that always have to be used, elements that can be used, and elements that must definitely not be used. We need to know about repeatability. Can I have more than one value for this element? We need to know the recording methods for your value. Is it structured? Is it unstructured? Is it an identifier? And we need to know if the certain ones of those are off limits, that no, you will only use this, or you have a choice. We also would want to know what's the source of the value for your relationship. Is it which vocabulary and coding scheme are you using? And then finally, you might need, especially with appellation elements, what's the string encoding scheme for that value? Or if you're making an imprint statement, what's the string encoding scheme for that? And I think one of the big things to emphasize here in an application profile is that you can do this in tabular form. We have some application profiles that have been posted on rdaregistry.info, but they could also be in prose. It could simply be a technical manual describing this is how you're going to describe a resource and this is what's available to you. Or it could be in the form of annotations in the RDA toolkit. Uh, the Library of Congress and the Program for Cooperative Cataloging have been putting in policy statements in the toolkit. So has the British Library, and so have the New Zealand libraries. That's a form of an application profile because it's telling you what options are available to you, what options are not, whether you're going to use this element, or maybe you're only using this element in certain circumstances. So as far as I'm concerned with application profiles, the more application profiles you can have, the merrier, because we all have different workflows where we come from. And I think it's best in a way to consider creating application profiles that are tailored to specific workflows. There's always a place for high-level application profiles. The PCC Bibliographic Standard Record that's being updated for use with the RDA Toolkit. That's an example of sort of a floor application profile. These are the things you need to include in order for your description to be considered a PCC description. But you can also do this locally. So I'm just providing a few examples. These are not exhaustive. For national libraries, legal deposits are a huge part of our workflow. So maybe you're creating an application profile that is specific to legal deposits. This is going to be becoming increasingly important as more and more things that would have normally be accepted as books in a legal deposit are now electronic books. Does that mean now that we could ask publishers to provide this set of metadata? And once again, RDA has a very low floor. So we could say, provide these elements to a publisher, and we would have the metadata that makes that record RDA compliant, for example. So something to think about. Maybe you're getting in collections that it's important for you to bring them in, but they only need to receive minimal treatment. Maybe that there's a staffing issue. Maybe it's more that for whatever reason, you can't spend as much time as you want. So you could say, well, we're only going to use these elements to describe them, and that's it. And then, of course, there are the specialized collections. So these are the things that are it could be a subject-based collection, and you create your own application profile for dealing with these things. It could be content-based. And then one of the more famous things are format-based ones. In fact, like things like audio recordings or video recordings and things of that nature. In a way, you can look back, if you go way back, you can look back at AACR2 as almost as a application profile for using AACR2 because it was divided up according to your format. Is it a book? Is it a score? Is it an audio recording? Is it a video? Is it an object, etc.? So we've reached the end of my presentation, and I want to thank you for attending. These are some addresses that you might want to make use of. The RSC Technical Working Group, of which I'm the chair, can be reached at techo@rdatoolkit.org. You can view the RDA registry. at http://rdaregistry.info. And of course, you can go to the RDA Toolkit at http://access.rdatoolkit.org. So just to put in another plug, we're always looking for more people to join the technical working group. And if you want to, please get in touch with me at this address. And I think I'm available for questions from the floor. So thank you.
Hello, everyone. Yeah, please type in any questions you have to the QA space, and we'll share them with Damian. We do have one question. Do the WEMI resources have to be distinct?
Well, I'll answer that from a technical point of view. In the modeling for the toolkit, a work is disjoint with expression, manifestation, and item. That means that if you say that something is a work, you cannot also then say that it's also an expression or also a manifestation. Now, in the flat file environment that many of us work in, a MARC record, for example, is an example of a flat file. You have the properties of all these different entities mixed up in the record. So it seems like in the record that, oh, this is also a work and also an expression or also a manifestation. But in technical terms, you just have different properties for different aspects of your resource. Some for the work aspects, some for the expression, and some for the manifestation aspects. But in a technical sense, a work is disjoint with the other resource entities, and that is the same for all the resource entities.
Okay. What is the relationship between RDA and ELSI's implementation of BibFrame? Is there full compatibility?
Okay. So from the RDA perspective, we are based on the LRM. In fact, we're compliant with the LRM, so we follow the structure of that. BibFrame has been under development before the LRM model came out, but it was started development during Ferber, which has the same entities. When BibFrame was first being developed, the resource entities, if you will, were BibFrame instance and BibFrame work. And then later that was expanded to there's also BibFrame item now. So the BibFrame expression element right now is the BibFrame work entity, I should say, has more akin to the RDA expression model. It's almost compatible with what an RDA expression is. BibFrame instance is compatible with RDA manifestation, and the same with BibFrame item with RDA item. There has been work going on in the development of BibFrame about the need for possibly the need for other resource categories, that sort of a super type that would take in the number of BibFrame works, something like BibFrame hub and stuff. But so there are differences between the models, but we can provide compatibilities in the way we map from RDA to BibFrame and how BibFrame might map to RDA. And I think the other thing to say is that I can't speak for the BibFrame folks, obviously, but BibFrame is still in development. So things can always change. And when BibFrame is at a point when maybe it's more people are using it and things like that, we could explore the mappings between RDA and BibFrame more fully.
All right. Our next question is, I work for a library system where we catalog items for libraries across the state. Would creating separate application profiles be a good way to document different or unique workflows we need to do for specific libraries? So creating an application profile for library A, another one for library B, and a different one for library C, etc.
Yeah, I think that application profiles can be helpful in that regard, especially if they're coming to you and saying, well, we really want our audio resources described at a high level. But another library comes to you and say, well, that's nice, but we only need, this set of elements. So it's a way for the content to be managed that you can say, well, this is the application for uh, institution A, and this is the application profile for institution B. I think it's certainly a way to manage the different requirements of each, for example. Um, and then this is getting into realms of um, that are sort of beyond me, but these could have implications for pricing models for people who are metadata providers, that a certain type of access is priced at this, but a more robust is priced at this, et cetera. So it's certainly a tool in your arsenal.
Okay. The next question, in what specific sense does RDA use the word semantic? Does it refer to the hierarchical structure?
Well, the reason why we talk about semantic coherency in RDA is that it's one way to think of it is as a hierarchical, but probably the better way to think of it is existing as sort of a graph with different nodes and different edges. But where the semantics come into play is because all of the RDA elements are connected with one another, you can do semantic reasoning with the RDA element set. A good example of what I'm talking about is if you remember the slide where we talked about the hierarchy of agents. So, a has screenwriter person is also a has author person, is also a creator person, is also a related person, then go up to the agent and all of that. So what could so the semantic reasoner can make the inference that, oh, if I have a has screenwriter person, this element also means that I have has author person, has creator person of work, has related person of work. So that's what I'm talking about within the semantic coherency, that you could make inferences about uh, an element just from where it is within the hierarchy. As I said before, you can only go up the hierarchy. So if you start at a very coarse area, you're not going to be able to make much inferences beyond that this thing is related to this thing. But if you start more granular, there'll be more opportunities to say more things about what you're describing.
That questioner followed up. So with this, so it's about how things fit into broader categories. Is that right?
That's correct.
Okay. We have another one. With the Mark 21 encoding, the new RDA instructions seem to be difficult to apply because all the entities are mixed up into a single record. The new RDA was designed to work seamlessly with kind of bibframe coding.
Okay, I think I see where you're getting at here, Robert. The part of the mission statement for the RDA is that it was to be developed to be in line with linked data principles and semantic web principles. So that is the base that we start from, so that the RDA element set is fully compliant with linked open data principles. Um, However, RDA, because of the different recording methods that we have in RDA, we recognize that most people right now are not in a linked data implementation. So we also provide other methods. And so one of those methods, we can go all the way back. You can still use the RDA toolkit to build a description for if you were typing out a catalog card. Now, the catalog card itself is not going to be able to interact with other things, but you could still say, if you wanted to label your line, or you had your string encoding scheme, ISBD all the punctuation and stuff is a good example of a string encoding scheme. So just by the placement on your card, you can say, well, if this is here, this is a value of title proper. Well, title proper belongs to manifestation. If it's here, it's this thing. If it's here, this is the other thing. So we purposely designed RDA so it can work with legacy systems as far as here's the element, this is the value you should have. But it's also designed to work with relational databases and crucially with linked open data.
Okay. Uh, Next question is, have you got any idea what the different application profiles and thus different choices regarding which entities and elements different institutions and national libraries choose to implement will mean in relation to data exchange and reuse of data?
All right. Thank you for the question. That's a good thing to bring up. So the way RDA has been developed is that the reason why we talk about semantic coherency is because we realize that libraries will want to describe things at different degrees of detail. And we can't have the same, it's nearly impossible now in this environment to have the same library, different libraries producing essentially the same description. We sort of rely, in a way, we already do this, right? If you're using a bibliographic exchange utility such as Skyriver or OCLC, something like that, there are times where you're making the decision or someone's making the decision, oh, we're only going to take, for example, PCC copy for this. That's all we're going to take. But then that same resource can exist in OCLC in another record, and maybe it's minimally described. And maybe you've made the decision that we only want minimal level descriptions, and can't get into the higher why of why you might make that decision, but it's a decision you could reach. So we already have descriptions of various qualities already existing in bibliographic utilities. So with semantic coherency, what that means is we at least want to have the ability for different linked data graphs to talk to one another and to realize that, oh, this thing over here has the same sort of semantic meanings at some sort of level with this stuff over here. And so it can have an impact. PCC is, currently developing a lot of developing a application profile, and they're wanting to do, this is the floor that we want PCC libraries to use for the things that they contribute to BibCo, for example. And that's fine. But we also know that in a lot of PCC libraries, they describe materials that they're not going to send in for consideration to BibCo because it's not their specialty. They only want to do it for certain things. So we already have the situation going on, and semantic coherency is a way to make sense of all of the data that is out there.
Okay, I think that's the last of our questions. So, oh, this will be the last one, just came in, and then we'll call it quits. If we go with a Descartesian view of things, I know that I think, therefore I am, but I can't prove that the rest of you actually exist. Much less can I successfully prove that a work, a distinct intellectual or artistic creation created inside someone else's head exists. However, the proof of a work exists through interacting with a resultant item. In essence, why is the model WEMI and not item manifestation expression work, not the inverse, instead? IMEW is also cat related, which is very library friendly.
IMU, very good. Appreciate the acronym. Well, in a way, you're correct that the only way we know about the existence, we deal. Let me back up here. In libraries, we deal with objects, whether those objects are real or they're virtual. That's the whole reason we are there. and we're there to provide our audience, whoever they are, with access to those objects. So yes, you're dealing with the object, and the thing that you're looking at, what you're holding tangible, is an exemplar of a manifestation. You're holding that item. But the manifestation itself is just the physical characteristics of this item. How big is it? Is it, is it bound or is it unbound? Number of pages, its dimensions, etc. Uh, why are you getting this object? Well, because there's thoughts that are expressed in this. And those thoughts are captured through expressions because they're conveying the content either through a visual sense or a hearing sense or a tactile sense, things of that nature. And then the top level work exists as a way to gather together similar expressions. Um, and that's the work being the most abstract. That's why we don't call it IMU versus WEMI. It is an interesting thing, but I think we were wanting to get at, why do people come to libraries, or why do people want to use the materials that libraries collect? Well, they want the intellectual effort that is in that, the creative effort that is in that. So that's why the model starts off with, in my opinion, starts off with work, which is the abstract idea, expression, how that idea is expressed through what visual senses, and then manifestation is getting that onto some sort of tangible object. And then we use the item to say if we've made some modifications to the physical modifications to the manifestation. I realize that might not be the most satisfying answer, but it might provide some insight there.
Okay, there's one last question. This is absolutely the last. See, somebody keeps just jumping in after I say this is the last question. So this is going to be the last question. Have there been RDA adopters outside of libraries? Is there a particular industry or creative area where RDA is particularly strong?
Well, I'll answer that by saying that RDA is developed for the library. It was developed for the library community. We do look to expand to other cultural heritage institutions, the so-called GLAM entities, GLAM groups, so galleries, libraries, archives, and museums. And as far as right now, I can't speak specifically to the adopters, but right now it's mostly libraries who are doing the adopting. And I know you said this is the last question, Jamie, but I do want to address this because
Okay.
it is being addressed in RDA. The question is, doesn't this mean that the model is upside down? Does that matter for the relationships? I think a lot of modeling questions for special collections could be addressed if it were flipped. RDA did implement a collections model. We're about to write guidance for this. The model is that it's sort of more what your idea of IMU, that you have the collections models, you have a collections work, expression, manifestation of item. That's a one-to-one-to-one-to-one relationship, meaning it's a WEMI lock. So your collection is the manifestation, and that's everything that is a part of that collection. And then that manifestation has holdings of the individual items that are within that collection. So this is going to be addressed in an upcoming release. And Eric van Balken mentioned in Holland, the performing arts sector is using RDA. So thank you for that.
All right. Thank you, everyone, for joining us today. And thank you, Damian, for an excellent presentation and an excellent post-presentation discussion. That was really good. So I will post this recording to the RDA Toolkit YouTube site, and I'll also post it on a blog. And Damian, if you can send me these slides, I'll post those as well.
All right.
And otherwise, thank you, everyone, and keep watching the RDA Toolkit blog for more webinars coming up in the future. All right. Thanks, everyone.
All right. Thank you.